So last time we solved in the system of equation 2 by 2. And that's relatively easy, right? You can do that in 662, right? Using elimination. Let me ask you a question. How many solutions can a system of equation have? How many types of solution can a system of equation have? 3, right? What are they? Infinite, one solution, and no solution. Yeah, that's it. Either you have one solution, infinitely many solution, or no solution. Give yourself all the check mark. So here today we're gonna solve this equation with unique solution. So one solution, unique mean one. Recall solving this 2 by 2 system equation. When I say 2 by 2, I meant two equation with 2 variables, right? So do you guys remember how we did this? When we try to eliminate, say we're gonna pick x to eliminate, right? So multiply the first one by first equation by 3, right? Because we try to eliminate x. So now I have a new system equation. I have what? I have negative 3x. Let me write small so I don't run out of space. Negative 3x minus 6y equal negative 12. And then rewrite the bottom one. So 3x minus 2y equal 4. And then what do? Yeah, we add, right? We add to eliminate. That's gone. It should be, if it's not something wrong. Negative 6y, negative 2y, that would be negative 8y, negative 12, positive 4, that's negative 8. Divide both side by, oh, something wrong. No, it's right? Yeah, y equal 1. Right. I'm not going to try to solve for it. The bottom line, my point here is that I go from 2 by 2 down to what? Down to how many here? 1 by 1, right? One equation with one variable, 1 by 1. And what do you do once you have y? Yeah, you plug it back, right? So you go back, you plug y back into the 2 by 2. Pick one, right? Pick one of them. So that is the process. Same thing if I give you a 3 by 3, you do the same thing, right? You start out with 3 by 3. I'm not gonna solve for this one. Maybe next time, or maybe next slide. And then during the process, you eliminate a variable, right? So you eliminate, pick one, doesn't matter, X, Y, Z, pick your favorite letter. Eliminate the first variable. Then you go down from 3 by 3 to 2 by 2, right? Well, once you have 2 by 2, you know how to solve 2 by 2, right? From 2 by 2, you eliminate the remaining variable, the second variable. Second variable, and then you go down to 1 by 1. Once I have 1 by 1, where do I plug it? So at this point, I have something solved for, either X or Y or Z, one of the letters. Yes.
You leave the number attached to the variable, right?
What is it?
Like you remove Z, you leave the 5 on 3 or 2, right? In the equation.
Z, the 5. Oh, no. I just say that from 3 by 3, you're gonna eliminate a variable, which I'm gonna show you how. And then you're gonna go down to 2 by 2. So something looking like that.
Oh.
Either you have X, either XY or XZ or YZ, one of the pairs, right? And then from there, you know how to solve 2 by 2, right? One by one. Now, what do I do? Once I have a variable solved for, what do I do? What do I plug back?
Plug it back into your 2s. And you plug it, right?
Do I plug back into the original or do I plug back into 2 by 2?
2 by 2.
2 by 2, right? Now, why do I plug back here? Say, for example, don't write this down. Say, for example, I have Z solved for. So I have Z equal 1, for example. Why do I plug Z back here? But I'd rather plug Z back into 2 by 2, something like that. And if 2 by 2 again, it's just tiresome, right? It's not wrong, it's just more work for you. So you reverse engineer, if you backtrack, you just go. So once you have the 1 by 1, you go plug in 2 by 2, and then now you have x and y, or x and z, right? I'm sorry, z and y, or z and x. And then once you have two variables, you pick one of the equations here, and you plug it back. So that's the process. I know it's a little abstract at first, but let's take a look at the problem. Before that, I gotta tell you how many ways to solve this equation. What I just showed you is called elimination. By the way, both methods called elimination, but this one is the one that we're gonna do next, and it's carrying out x and y and z. The second one is called Gauss-Jordan method. We're gonna use matrix. Has anyone used matrix before? I know you do. Matrix to solve equation. Really? Oh, they're supposed to teach you a 62. You did? Okay. Good teacher. So how do I do method of elimination? I can interchange any two equations. What does that mean? What does that mean when I say I can interchange any two equations? Change them around? How? What do you mean change them around? In what order? Yeah, yeah, very good, right? I can shove this one down here and then push this one up here, right? And maybe this one here. It doesn't matter. It's the same thing. It's still inside the system. I can replace an equation by a non-zero constant multiple of itself. What does that mean? We did this before. We just did it. I mean, I can multiply both sides by a non-zero number, right? Like I did here. I multiply both sides by 3 for the first equation. As long as it's not 0, you can multiply both sides by any number, except 0. I can replace an equation by the sum of the equation and a constant multiple of any other equation. You did this also. Right here. You replace the add these by the sum of one equation to another multiple of another equation. Replace this one by an equation. So you can do that. So let's take a look. If I was you, I'll label them 1, 2, 3. Try to write small because it's going to be a little bit long. Start from the left. All right. I'm going to eliminate one variable. Right now, I got 3 by 3. So I'm going to pick two equations and then eliminate one of the variables. Which one you want to eliminate? Very good. Why? Yeah. Yeah, easy. It doesn't matter which one you eliminate, really. Some people like to eliminate x, which most of us do. Right? Some other people like to eliminate y. Some other people like to eliminate z first. It doesn't matter. So equation 1 add equation 2. What is the new equation?
Y plus y.
Very good. I'm going to call it equation 4. The one in the circle means number of equation. All right, I want you to pick another 2 pairs, not 1 and 3 again. It could be 1 and 2 or 3 and 2, but not 1 and 3. And then you eliminate the same variable. Stick to the same thing. You decide to eliminate x and just stick to x. So pick another two equation and eliminate x together. Which one you want to pick? All right, middle and bottom. I like it because they already opposite, right? One is positive, one is negative. All I have to do is multiply both sides by 3. Yeah, 3. Darn it. Just do it there. Excuse me. So I'm gonna say 2, equation 2, add 2, 3 times equation 3. Equation 2 is, I'm going to rewrite equation 2. So 3x plus 8y plus 5z. You can do it in your head, but that's easy to make mistake. Negative 3x minus 3y minus 6z equal negative 6. And then you add. Oh, positive 6. Thank you, Gary. Yeah, thank you. I don't know why I put negative. Oh, because I bought the negative x. Yeah, thank you. Yeah. All right, very good. Imagine you do that on the exam. Math is cruel. One little step wrong, the whole thing just garbage. Which I'm not gonna do that to you. I'll give you partial credit. AY plus 3y is 11y plus 11z equal 33. Can I reduce it? Can I divide by 11 to make it smaller? Yes. Y plus z equal 3. It's the same thing. You don't want to, you can keep it like that. But I just like it simplify it as much as possible. I'm gonna call it equation 5. You see why we had to stick to one variable? Imagine somebody eliminate y instead of x. And what kind of variable you had in the last equation? Hypothetically. X and z, right? Which is not matching that, which is you're gonna stop. So I'm gonna combine the 4 and 3. Y plus 5z equal 13. Y plus z equal 3. It doesn't matter which one you eliminate. Multiply the bottom by -3. I want to eliminate y. Rewrite the first one, 3y plus 5z equal 13. The bottom one would be negative 3y minus 3z equal negative 9. Then you add. That should be gone. 5z minus 3z is 2z. 13 minus 9 is 4. Z equal 2. Why do I plug z back? I got one down, 2 more to go. Why do I plug z back? Which one? 1, 2, 3, 4, 5. Which one? Yeah, 4, 5, right? Don't look back. Not yet. The reason is just make your life easier. It's not wrong you look back to the original, but then you have another 2 by 2. Right? So I'm gonna rather plug back either 4 or 5. I like 5 because it's the simplest one. So plug back to 5. I got y plus 2 equal 3. Z is 2. Y equal 1. Now you plug back to one of the 3 by 3, right? Pick one, doesn't matter which one. Maybe I'll pick the first one because this looks nice. Number 1, I have x plus 2y, so 2 times 1 plus 3 times z, which is times 2. I write in red here for you. Z is 2 equal 11. 2 plus 6 is 8. Subtract 8. x is 3. So your final solution will be 3, 1, 2. Make sure you write in order pair. So you guys have got the idea now? Yeah. Just pick one variable and eliminate, right? Why don't you try this one? I'll walk around, see how you do. Write down, and then I'll leave it at the other slide so you can take a look at my work. When you want this at home, you can just fast forward. Right, so you can take a look at my work, and I recommend you try to be neat, and be organized. The problem it's easy, but very easy to make mistake as well. Mm-hmm.
Was it 4 and 5?
4 and 5, yeah, thank you.
Yeah.
I say 5 or 3. Did I? What did I say? But then I wrote 3. I guess the banana wasn't enough. I didn't have breakfast yet. My bad. Oh, yeah. No, I just voted wrong. That's okay. I accept 5 or 3. I have no idea how it is. Have question? If you have question, please ask. Lexi will help you as well. Who chooses to eliminate y first? Raise your hand. Good. So we're gonna do put on that line. It doesn't matter which one. It's just easier for you. Lexi will walk around. You have question, ask her.
Oh, okay, right. 3x. Right. Yeah. You need to do that again. Oh,
Yeah.
Oh, like, yeah.
Yeah.
So we need to multiply. Wait, why are we? Oh, so it's both.
Because the answer, because I will shoot it right, yes, and I just correct.
by there.
Yeah, okay. But now you're supposed to submit it.
Or X. I'm like you, right? Because I can't. Oh, are you? No.
Yeah.
What do you think is wrong? Negative. Wait.
If you want to, yeah, we can do that one. Yeah, I know,
Right.
I think, yeah, let's have a negative 3, yeah, that would be. Yeah. I would say, I don't know, but that she, that's what she. So I would just. And then.
This is the most tedious math.
Right, okay. For what? Whatever starts. Yeah. But did you multiply? I bet you. Oh. You know what I? I'm like, yeah. Yeah, that's why. Angela, thank you. In the meantime, I will return to exam the quiz. Kristen. So, right here you have, so you're adding these right here. That's like it's 3 plus 12. Oh, you're fixing that one. Right. So now, yeah. Right, so now you just have to see like where that would.
This one.
Hold on.
Right. I'm very unorganized.
Luckily, because that's what you're able to do, honestly, you should have changed that much of the problem if it was accidentally you're multiplying with the wrong. But because it's just the adding action. This is well, this was all fine. So this,
I mean,
right? So this is all fine. Because that's the other right, because this is going back to your original. So this is what has changed.
so I just would go with it.
You're right.
You do the Y's first, the Z's first, the X. I like to do the Z's first. No, that's all it is. Hey, sorry. Cancellation. Cancel stuff out.
Michelle.
What am I missing? Oh, yeah. I was going on. Amy? Father?
Seven Y minus five. I got all the-
Maddie? Anthony? Oh, it's like. Oh, okay. How did you I did, yeah. I've got
All right, what you guys have? What's the solution? All right, good. Give yourself 2 bonus check mark. I think that's it. So I'm gonna pick Y to eliminate because it's just right there. It's easy. Somebody else can pick X. It doesn't matter. You should have the same solution. So I'm gonna say equation 2 add to equation 3. 4x. Let me write in red. 4x minus z equal 9. And I'm calling this equation 4. Pick another one. If you don't do like I do here, please circle it or something, okay? Because if you work all over the place and I can't, it's difficult for me to grade you. Rule number 1 is make your instructor happy when they grade your paper. Okay. All right, I gotta eliminate y again, and then I gotta pick a different equation. So which one? Top and second?
Yeah.
Because they already opposite. So I'm gonna multiply the top by 2 and the bottom of the second one by 3. And I gotta rewrite this because I don't want to make a mistake. So 2 times equation 1 add 3 times equation 2 4x plus 6y plus 2z equal 12. And then 3x minus 6y plus 9z equal negative 9. Let's cancel. I have 7x plus 11z equal, God, I can think 3. Combine 4 and 5. Again, people who didn't do well on the exam too, don't be discouraged, right? Think about your extra credit at the end. You have a chance to earn up to 15 points. Imagine you have 15 points right now adding to your exam too. That's a lot, right? So don't be discouraged. You still have exam 3, which is I think is gonna be easier than exam 2. So make sure you study, then you'll be fine. 7x plus 11z equal 3. All right, I'm gonna eliminate z because it's easy, right? I just need to multiply the first by 11. So let me rewrite this. 44x minus 11z equal 99. Rewrite the bottom one. 7x plus 11z equal 3. Add them. That's 0. 44 plus 7 is, what is that? 51x equal 102. Divide both sides by 51. X is 2. And then you plug it back to where? Yeah. 2 by 2, right? Because plug back into one of the 2 by 2, which is I'll say Z, number 4. This is 4. You can pick 5, doesn't matter. 4 times 2 minus Z equal 9. 8 minus Z equal 9. Z equal -1. And then you plug it back to one of the 3 by 3. I'll pick the no, I'll pick the first one. So 2 times x, which is 2, plus 3y, y we don't know, so leave it, plus z, which is -1, equals 6. So y equal what? 4 minus 1 is 3. Y equals 1? Is it 1? Yeah. And then you're gonna write your solution, so run out of space here. 2, 1, -1. Solution. You're gonna have one like this on the exam. Count on it. Okay. All right, so that is elimination method. The next one is gonna be Gauss-Jordan method. In order to do that one, we need to talk about matrix. Not the movie, but since we're here. Huh? Yeah, the first one was good, right? I was really impressed with that scene when they dodged the bullet. Consider the technology they had back then. That's pretty cool, I thought. Of course, they can do it easier nowadays. You know how they do the adventure. Did you know that William Smith's supposed to take the role, but he turned it down? He said that, that's kind of weird concept. Well, he should have taken it, didn't he? I think this movie made his name. Will Smith was supposed to take the role. He's the one who got the script first, but he turned it down because he thinks it's weird. It's a good movie. The last one sucks. The one with the very, very new one. Oh. I don't want to be discriminated, but it was directed by a woman. They have a different mindset. Too much political, input in there, which I don't care for. It's a movie. Let me enjoy it. Right. So matrix here, what we talk about is not the movie, is the rectangular array. If I have first row, let me move it to the right a little bit. I don't have enough space. If I have the first row and the first column, then the first entry will be denote A sub 1, 1. Rows always come first. Row always come first. So first row, first column. If I have first row, second column, then what? So I'll move it out here. So then what this one equal? I'm sorry, what this one denote? A sub what? 1. First row, yeah, 1, 2. First row, second column, right? First row, second column. So 1, 2. All the way out here, if I have n columns, the nth column, then what this one? A1n, right? A1n, right? Always the first row, A1n. Then if I have a second row, first column will be A21, right? A21, and then A22, and then all the way out there. If I have mth row, then what this one? M1, right? M1. And all the way out here, the last one will be A sub Mn, right? M row, N column. Done, it is, yeah, so right here, like that. I'm not gonna examine you on this. I just need you to understand, that's all. So this is the matrix we call, this is the matrix with, let me write it in red still, with M row, M by N, where M is the number of rows and N is the number of columns. So Aij is what? I is the location of the row. And J is the location of a column. Let me give you an example to make up one here. 3, 6, 0, 10, 9, 7, 1, 5, 2. What's the dimension of this matrix? Very good. Always, rows always comes first, right? So 2 by 5. I'll write like that. Actually, I'll write like this. Usually I write next to the matrix, like it's a little bit like a little script with 2 by 5. So that's matrix. Now why do we do matrix? Now why do we use this to solve system equation? Yeah, very good. Computer. That's how computer do it, right? They're not gonna do it like us. They're not gonna carry the x and y and z every time, right? And it's just not practical. If you have 3 by 3, fine. 4 by 4, maybe a little bit. You maybe white a little bit. But imagine you have 100 by 100 or 1,000 by 1,000. You don't want to do this. So we're gonna use matrix. So this is how we're gonna convert the system equation into matrix form. It's called the augmented matrix. It's derived from a system of linear equations. So for example, if I derive this like this, then I'm gonna draw a rectangle, or close the big bracket, you know, matrix, right? The equal sign I'm gonna replace with the line. So that equal sign here, side of the line. The right side of the vertical line is gonna be the constant column. So 1, 5. It's called constant column. And then the coefficient matrix, which is the left-hand side, which is like the name suggests, the coefficient of x and y. So it's gonna be 1, -3, 1, 2. And this right here is called coefficient matrix or coefficient columns. It's just terminology wise, it's not something I tagged you, but you should be able to transform from system equation to the augmented matrix. Why don't you guys do number 2? Just tell me what you got. walk around.
I'm really comfortable. I really I like that.
One, -3, 1, 2, 1, -1. This is what you got? On the exam, if you be able to do this, since you write this before I do anything else, I'll give you 2 points. So get it right. Every little thing counts. Everything counts. All right, so that part is done. You'll be able to convert from system equation to matrix form. Now, once I have that, what do I do next? Then 2 things. One for us, one for the calculator. Huh? So once you have that, what you're going to do is there are 2 things we're going to do. We have 2 ways of solving that. One is called row echelon form. The other one is called row reduced echelon form. These are French. Sounds like unlike German. Row reduced echelon form. This one I'm going to use calculator. I'll show you how to do calculator. But this one we need to do by hand. This is the work you show me. You show me on the exam. Now, what's the difference between the 2? Well, you can read on your own time, but the main difference is that, well, let's do the same first. Same thing is that both have a diagonal of 1. The difference is that for row echelon form, which is REF, the only thing needs to be 0 is the lower triangle. So anything below the diagonal has to be 0. 0 here, 0 here, 0 here, 0. Row reduced echelon form, REF, which is your calculator is going to do, anything below the diagonal and above the diagonal are 0. This is a long one. If you do by hand, it's really long. So I'm not going to make you do that, but you need to show me how to do this. Long story short, I give you a problem, you be able to tell the answer just by plugging the calculator. Just have to show me the way. It's really helpful if anyone take linear algebra or differential equation, because no one show you how to use calculator on this. My classmate, I remember when I took the class, they would get it wrong all the time because it's really easy to make a mistake. Right? But for me, I'd be able to check with my calculator. I know where I got it wrong. So I go back and fix it. So you're not cheat, but yeah, less likely to make a mistake, right? All right, so the method is this. It's very much the same, right? I'm allowed to interchange any 2 rows, flip back and forth. Right here, I can flip row 1 down here and row 2 up here. I can multiply a row by any real number as long as it's not 0. Say I can multiply the row 2 by -3. And I can add a non-zero multiple of 1 row to another row. Do you guys remember we do that? We did this here. Up here. You add multiple of 1 row to another. Remember that? And then you got new equation. You can do the same thing with matrix. It's just another form of elimination. The difference, you don't carry along the X, Y, Z, that's all. But it's pretty much the same. So for example, I can multiply row 2 by -3 and then add to row 1. So row 2 stay the same. Row 1 is the one that's gonna change. So -3 times 2 is -6. -6 plus 5 is -1. -3 times -1 is +3 plus -3 is 0. -3 times 2 is -6 plus -1 is -7. Something like that. Let's take a look at the one example. We do this by hand. I'll show you how to do calculator and we'll call it a day. Okay. First, you're gonna change it into augmented matrix. Two point, too easy point. Don't mess it up. One. You can flip the row if you like. Usually, I like my first entry to be 1. Let's do that. So flip. So I'm gonna do this. I'm gonna do like this. Like that. I want R2 change, right? So 1, 1, 2, and then 3, 2, 1. Please don't forget the line. What row echelon tell you to do is that everything under. Oh, by the way, the diagonal will be this one. This is your diagonal. It doesn't have to be 1, 1 everywhere. It's okay to be not 1. But at the least, I like my first entry to be 1. If it's not 1, it's not gonna ruin anything. But I just like it that way. Everything below the diagonal has to be 1. 0. 0. Remember what I say here, right here. 0 right there, right? So this needs to be 0. So what do? I'm gonna so in order to be 0, I have to have a -3 after that, right? So what I'm going to do next, I'm going to take -3 times row 1. Add to row 2, and then I got new row 2. The arrow implies which row is going to change. It's always the second one. So what happened? Row 1 stayed the same, right? So I'm going to rewrite row 1 so I don't forget. 1, 1, 2. And then let's do row 2. -3. -3 times negative. No. -3 times 1 is -3. Add 3 is 0. -3 times 1 is -3 plus 2 is -1. Add to the second, yes. -3 times 2, which is -6, plus 1 is -5. And then we stop because we have 0 under the diagonal. Remember, this is your diagonal. That's your diagonal. It's not negative, it's just me. So now I'm gonna back substitution. What do I mean by that? I'm gonna convert it back to xy system equation. So I have 1x plus 1y equal 2. And the second one I have 0x, which I'm not gonna write it, minus 1y equal -5. You have y equal 5. Once you have 5, you can plug it back. You can plug it back here. Or there. So when y equal 5, what's x equal? Yeah. All right, let me show you how to do this in calculator. I'm not done yet. Sit down, sit down. One minute and I'll let you go. X inverse. Second, and then X inverse, you see that matrix in blue? Press the second. And then go over edit. How many, what's the dimension? 2 by 3, right? So you want to put in 2 by 3 there, 2, enter, 3, enter. And then you plug in the coefficient. Can you read it for me, Gary? Was it the very original? Okay, I have it there. All right, 1, 1, 2. So press enter. Now as you have it, quit, second mode to quit. Go back to the matrix, second matrix. Go over math. And you go all the way down. RREF, very good. RREF. RREF right there. Row reduced echelon form. And then it asks you what matrix you want to plug into there. Second matrix again. And I put it in matrix A, so press enter. There's your solutions. So on the exam, you have your solution. I give you the answer. Show me the word. So X is negative 3, Y is 5. The last column. All right, that's it. Thank you. Have a good one, and I'll see you Friday.